My name is Nazik. I am Turkish, but it has been 10 years that I've been changing countries. I studied my bachelor's degree and master's degree in Turkey at Istanbul Technical University. In 2014, I moved to Italy for my PhD as a Marie Curie Fellow. And after that, I changed countries. I've been in Germany, I've been back in Turkey, I've been in Saudi Arabia, and currently I'm in Portugal at Center for Marine Sciences as, again, Marie Curie Fellow. And today, I really would like to introduce you some new words that I hope that you will be associate with them in your daily life. Let's see how it will go. So I am a geoscientist and I am specialized in micropaleontology and stratigraphy. But I would like to start with stratigraphy first. It is not so complicated, in fact. Stratigraphy is the science of describing rock layers, and it is the fundamental part of geological science. And the person who does this description, classification, and analysis of geological rocks layers is called stratigrapher. So how does it work? I will give you an example. For example, you are in a car and you're in the mountains, you're driving, and you go through a road cut, that we would say. On your right and left, you see lots of layers of rocks. Well, the study of examining those rock layers is stratigraphy. So on the road that you drive, you can see those rock layers. And if you study this science, then it makes you a stratigrapher. So you can become an amateur stratigrapher yourselves in your daily life, in fact. So what is the basic principle of stratigraphy? It says that the lowermost rock layer should be the older one, and the topmost rock layer should be the younger one. And whatever there is in between that cuts through those layers should be the youngest that you should ever see. So, for example, you can consider it like making a sandwich. You first put first layer of your bread, your sandwich bread, like this. It makes you the oldest layer. Then you put cheese, makes it younger. Then you put tomatoes, that makes it even younger. And then you put the last slice of bread, that makes the youngest layer. It is like the rocks. And when you cut that sandwich into half, it is the last thing that you do to those layers, and it is the youngest thing happen to your rocks. So these are all the basic principles of stratigraphy that we apply. What I do is to look at the fossils in those rocks. Yes, and when we study distribution of fossils in rock layers, it is called biostratigraphy. So how does it work? We know that dinosaurs are extinct, for example, right? When we find bones of dinosaurs, we know that that layer should be maximum around 65 million years. It cannot be any younger because dinosaurs got extinct. So, but what I specifically do is slightly different. Now, paleontology is a science that deals with the life of past geological periods. For example, here we have a giant pneumalite. You don't see it as behind, but maybe now you can see. I'm trying to move my screen. Here you can see a tail of dinosaur. A paleontologist find those rocks. But what I do is I deal with tiny little organisms, so little that I have to use a microscope to see them. Through a camera, I can see what's inside and I can make their pictures. So when we deal with those tiny little organisms that can be studied only with the help of a microscope, it is called micropaleontology, and it is a branch of paleontology. So when I look at those tiny little organisms, what do I see? I see many things in many shapes. For example, I see foraminifers, which are my expertise. I will speak about them later. I see ostracods. These are little bugs of the sea, we can say. You see, for example, there is a small bug inside, and these are like shells that is covering that organisms. We see coccolithophores. These, for example, live at the surface waters. They are in fact microalgae. We see radiolaria. These are found in very deep ocean waters in very pretty shapes. We see, for example, I'm sure that you know this word, pollen, and maybe some of you have allergies to pollen. We even can see pollen grains studying micropaleontology under the microscope. We see diatoms, these are also microalgae, and we can see pteropods. These are very tiny little organisms that we also call them sea butterflies, and these are endangered because of global warming. Anyway, going back to my expertise on foraminifers, I would like to give you some more details about that. Foraminifer, in fact, is a Latin word that means hole bearer. Do you see this picture, for example? There are those little holes. These organisms use these holes to absorb some food and oxygen, and some of them have even pseudopods. These are kind of tentacles. And let's see if this video will work. Do you see it?
Yes, of course.
Okay. These organisms with those tentacles, you see, is able to catch a little shrimp to eat it. So these are so tiny, but they're also predators. So these are also so tiny that their average size is almost less than 1 millimeter. You see, this is a regular ruler that we use, and these tiny little organisms are only as big as this tiny little fraction here. These organisms are monocelled, single-celled organisms, microscopic, and they occupy all the world's oceans and some lake environments. So since they are in all the world oceans, it is kind of easy to reach and study them. So going forward, how you can associate, how do you catch them? For example, when you go to the beach, you can get a piece of sand from the beach. You see those star-shaped organisms, for example? These are foraminifers. Maybe next time when you go to the beach, you can try to see some of them. Even, for example, that circular one here, I know that is a foraminifer as well. That is similar to this one here in this picture. You see? In fact, they're pretty accessible. And we can even study them to understand the health of corals, coral reefs. They are kind of indicators. There is one fact about foraminifer. When it was first time to describe foraminifers, it was not in fact that someone described them. It was Strabo, a Greek geographer at 1st century before Christ. He studied the rocks that made Egyptian pyramids. And you see those rocks, when you give a close look, they have inner structure like this. And he thought that these were the leftover foods of the workers of pyramids, like lentils, because those foraminifers, which are in fact nummulites, they look like lentils. So at first, the first description about foraminifers were not because they were foraminifers. They thought that they were lentils. But let's give a look. How do we get those microfossils, microorganisms, right? As I mentioned before, for example, simple road section, we can call those land sections, could be an environment that you can collect samples. For example, this picture belongs to my field that I studied during my doctorate degrees in Turkey. And I looked at its microfossils, and I was able to identify the oldest part of this rock layer just because I found this fossil. And then I was able to identify the youngest part of the rock because I found this fossil. So these fossils give us age. So, as I said, a simple land section could be somewhere that you can collect samples to study microfossils. The other one is more complicated. Like in the first talk, Anjali was speaking about the research vessels going on the ocean. It is the same thing also for micropaleontology. We use those giant research vessels, those ships, to collect sediment cores. What is a sediment core? It is simply a pipe shaped like this with a diameter of 10 centimeter. we call them liner. We send it to the bottom of the ocean, and we collect a series of mud sediments, like in this picture here. And we know that the top layer of that mud will be the youngest, close to the present day. And as we go deeper, we would go older. So we can study the past of the ocean and climate just looking at the microfossil content. So how do we get the samples when we collect them from the land sections or from the ocean? So simply we use a sieve, it's like a drainer, and we wash the mud with pressurized water until we collect the grains only, bigger grains only. And then we put them on a filtering paper like this. And after that, we just put it in the oven at low temperature, around 40, 60 degrees. So what we get is similar to sand that you collect at the beach. And then we put the sand on a tray like this. We look at under the microscope. And using a simple painting brush, we can collect each foraminifer individual in a slide like this. And we want to identify their species, then we use a different microscope slide, big like this, and we put all the similar individuals in allocated squares, and we can glue them as well. So this is how we work with the samples. But let's look at the things, more important things. What do we do with microfossils? And why are we using them? As I mentioned before, they occupied almost all entire world's oceans. It means that they are very abundant, they are easy to access. We can collect lots of them and we can get very reliable data with them. And they record the environmental conditions that they lived inside. It is the climate, it is the atmosphere, because the oxygen comes from there, or it is the food nutrients within the ocean, it is temperature, it is the salinity. And since there are lots of them and they've been living on Earth since the last 500 million years, we can have a very long fossil record throughout the Earth's evolution, especially for the oceans. So a micropaleontologist uses them to study the age of rock layers, so to apply biostratigraphy, because this is very important. A good age constraint is the foundation of every geological study. Without knowing the age of the rock that we study, our information is inconclusive. So we have to understand what is the age of the geological events or climatic events. So a micropaleontologist's task is to understand the age of the rock, and then to study past climates and oceans. You see, this is a section from an ocean, in fact. This is the bottom of the ocean, and we have some foraminifers here and here, as you can see. So they record every single environmental and ecological condition of the waters that they lived in. So it is the oxygen, it is the climate forcing, which is the temperature, it is the nutrients. So we can study all these things to understand how the oceans and climates evolved. We can understand what was the geological history of the sedimentary environment when they die and they settle to the bottom of the ocean, what has happened there. And we can understand what was the past ecological condition of aqueous environments. So it doesn't have to be ocean, it can be lake, it can be river. So the organisms, the small organisms that will live in different environments will be different too. So we go to the next slide. And what I do specifically for my current research is that I use microfossils to understand past climates. And how I do that? We know that our ocean is circulated by water masses, and their circulation is called thermohaline circulation. As the name suggests, it deals with temperature, thermo, and salinity. So the movement of ocean currents due to the difference in temperature and salinity in different regions, because they create density difference due to the temperature and salt inside, is a climate regulator, and this ocean current is called thermohaline circulation. It covers the entire worlds of oceans. So what do we have that? Warm waters occupy the surface part of the ocean, and cold waters occupy the lower part of the ocean. That much we know, but how was it in the past? So to understand this, I used foraminifers and I studied their chemical composition, because these organisms have shells like those mussels that you collect at the beach, right? They have shells, or like snails. Those shells record the chemical composition of the waters that they used to live in. And we know that if those shells, which are made of calcium carbonate, consist of other trace elements such as magnesium, it gives us information about the temperature of water. And if it contains sodium, we will know that it is about the salt of the water. So we can understand how this thermohaline circulation in terms of temperature and salinity changed in the past. So I hope that you have heard the new words, and now you can look at the ocean, the beach, or even the roads that you pass through with car in a different way. And maybe you can become even amateur stratigraphers, amateur micropaleontologists. For example, at home, I have a little microscope that I bought on eBay, and sometimes I just attach it to my laptop and I just look at my hand or whatever, some soil that I collect from my garden. So maybe you can do the same, and maybe from the beach sand that you might collect at the beach, you can see some microfossils. So I hope you enjoyed what you have heard and what you have seen. And if you have any questions, it will be a pleasure to answer them.
Thank you so much, Nazik, about this beautiful presentation.
You're
I
very
think
welcome.
that the presentations today are dominant from the oceans, at least, and things that are concerning the oceans.
Modern topic.
Yes, yes, but I believe this is an issue that it's burning to our lives, of course. So that is
True.
why it's prominent. So thank you very much for the presentation,
You're very
guys.
welcome.
Again, you can either write your questions about Nazik and the presentation on the chat, or even raise your hands, or do any other kind of um, reaction you would like to have. But also, in the meantime, because I have a small question in the meantime for the
Yes, please.
presentation, uh, it, because I'm not sure I understood it correctly. So you find the same organisms in the soil found in the deep of the ocean, for example, and the same one that you can find in the rocks outside in the land. You find the very same organisms
You can.
in the both ways. Oh, okay.
Yes, you can. It depends. Now, since ocean has different depths, with depths species change. But let's say that uh, we are at 500 meters depth of ocean and we collect some samples, and then you come across with land section, right? And you can find exact same organism. So you can associate, okay, it means that this land section is supposed to be 500 meters underwater, but it
Oh,
is
okay.
not. Why is that? And this is what we study. Why that land section is not underwater today? Because continents change, mountains form. Apparently, that land section was formed underwater, but throughout the geological history, Earth's evolution, something happened and it came to surface.
Mm-hmm. Mm-hmm.
And this
Understood.
is what we study.